Hi. Okay, so I'm going to attempt to explain this problem. Um, so the problem is, it's wrote down, so show that integral on C, a contour C of f of z dz is 0, and then C is basically the unit disk, and they tell us that f of z is log of z plus 2. Okay, so this is capital L log, which means it's the principal branch of log. So that basically means you're restricting the arg values to from negative pi, strictly from negative pi to pi. So once you do that, it becomes like just a normal like single valued function. And we also proved before that if you have any branch of a logarithm, then any branch of log of z, then the derivative, it has a derivative on the entire branch, and the derivative is 1 over z, right? Okay, so yeah. So if you write out the expression for log, it's that. So basically, there's two conditions if you have a branch, or if you're dealing with log and if you have a branch. First condition is that it has to be non-zero, because of this ln thing right here. You can't take a ln of like a 0. So that's one condition. And then the second condition, the second condition is that, like we talked about, the principal argument has to be between negative pi and pi. Okay, so for the first condition, it fails when the modulus of z plus 2 is equal to 0, and that just happens when z is equal to negative 2. So we know that this log of z plus 2 is not defined when z equals negative 2. That's not really an issue because it's outside of our unit circle C, right? Because it's on the axis, and it's at negative 2, which is beyond the negative 1. Okay, so for the second condition, so basically we cover all possible angles, right? Negative like negative pi all the way around to pi, except the actual pi, because it's a strict inequality. So what happens if it's pi? So if it's pi, then what you have is you have z plus 2. So we're taking the principal argument of z plus 2. So assume that z plus 2 has argument pi. And then let's just see, like, we hopefully don't want it to be on our unit circle. Oh. Okay, running out of time. Okay, so you have z plus 2 equals r e to the pi I, and e to the pi I is negative 1, so you get z is equal to negative r minus 2, which must be less than or equal to negative 2. So now you know that whenever you have an argument of pi, then it's going to be to the left of negative 2, which is still not going to be in the unit circle. So basically, all the points where log is not defined, which means it's not analytic, which implies it's not analytic, those are all outside of the unit circle. So that means we can apply the Cauchy-Grassot theorem, which tells us that the integral on C of f z dz is 0.